Light moves fast. So fast, it circles Earth 7 times in a single second. So fast it could take you to the moon in less time than a heartbeat. And yet, not infinitely fast, not instant. It's not omnipresent. That matters, because the universe doesn't run on absolutes. It runs on limits. The speed of light is not just a speed. It's not even about light. It's the boundary of influence. The maximum rate at which anything, information, matter, even causality can travel. If something happens far away, the effects won't reach you immediately. There's always a delay. A pause between cause and consequence. And that pause is sacred. Without it, cause and effect would blur. Actions would arrive before intentions. Events could precede their own beginnings. The laws of physics would become a hall of mirrors, beautiful but broken. But the speed of light holds it together, not because it's fast, but because it's finite. It defines the edges of now. It's a boundary between here and too late, between knowable and forever out of reach. Every star you see tonight is a story from the past. Every moment of vision is a memory delivered just on time. Light doesn't just let us see, it lets us sequence. It turns the universe from chaos into a story. And it sets the rhythm of time itself. We tend to think of speed limits as obstacles, things we wish we could break, but this one is the reason anything makes sense. The speed of light is not just the limit of motion, it is the limit of causality. And that changes everything. There are numbers in physics that feel almost mystical. The gravitational constant, Planck's constant, the fine structure constant, strange, dimensionless, and seemingly carved into the bones of the cosmos. But one number stands apart, not because it's the most mysterious, but because it's the most definitive. 299,792,458. That's the number of meters light travels in a single second. In a vacuum, it's not an estimate. It's not even something we discover anymore. It's defined, baked into how we measure everything else. The meter itself, the unit we use to measure all distances, now pegged to this number, because that's how reliable the speed of light is. It's not just a benchmark, a pillar. But here's where the real twist begins. Despite the name, the speed of light isn't really about light. Light just happens to obey it. But the limit belongs to the fabric of space-time itself. Any massless particle, anything that carries no rest, mass will move at this exact speed. Photons do. So do gluons, at least theoretically. And gravitational waves? They also propagate at the speed of light. This isn't a law that only applies to lasers and flashlights. This is a law that shapes how information moves in the universe. It is the speed of causality. Why is this strange? Because it forces the universe to behave in unexpected ways, you might think. If I move fast enough, if I push hard enough, I can go faster. But that's not what happens, no matter how fast you're already going. No matter how much energy you pour in, you can never reach this limit. Instead, time stretches. Distances shorten. The universe itself bends to prevent you from crossing that line. It's not a wall you smash into. It's a horizon that keeps slipping farther away the faster you run. And light? Light just follows the path space-time allows. It's not trying to be special. It's just the one thing fast enough to keep up with causality. The real revelation isn't that light is fast, it's that nothing can go faster. And the universe treats that as sacred. This tells us something profound. Space-time isn't just a background where things happen as rules. It reacts to motion, it protects consistency, and at the center of that protection is this one unbreakable rule. Information cannot travel faster than light, because if it could, the future could affect the past. Cause could arrive after effect, and everything. Reality, memory, meaning would come undone. We don't often think about it, but when we say, this happened because of that, we're invoking the speed of light, not just as a speed, but as a boundary between logic and chaos. You might expect that the speed of light would vary depending on how fast you're moving. After all, if you're running toward a wave, you meet it sooner. If you run away from it, it takes longer to catch you. But light doesn't care how fast you're going, whether you're standing still, racing through space, or free-falling into a black hole. You will always measure light moving at exactly the same speed. Always. This seems impossible. It feels like a trick. But it's not a mistake. It's a fundamental property of how the universe protects causality. In 1905, Einstein didn't just propose that light was fast. He proposed that its speed is constant. No matter who's measuring it, no matter how fast they're moving, to preserve that constancy, the universe makes a trade. If light won't bend its speed, then time must bend instead. So does space. So does your very sense of simultaneity. The faster you move, the more your time slows down relative to someone at rest. Your clock ticks slower, your heart beats more slowly, your thoughts stretch. And it's not an illusion, it's not a mechanical effect. It's not because your watch is malfunctioning, it's because time itself is flowing differently for you. At the same time, your length contracts in the direction of travel. To someone watching from the outside, you appear thinner, shorter, compressed by your own motion. All of this happens to preserve one sacred truth. No matter what, light always moves at the same speed in a vacuum. It's not the speed that changes, it's everything else. And here's where it gets stranger. This isn't just about light, it's about information. The universe ensures that no signal, no cause, no particle carrying energy or data can ever outrun that boundary. Why? Because if anything could break that rule, then one observer's before could be another's after. You could send a message into your own past, and physics would unravel. The universe would become unpredictable, incoherent. Not because objects are chaotic, but because logic would cease to have a single direction. To avoid that collapse, reality chooses to bend rather than break. It curves time. It compresses space. It twists your understanding of when and where things happen. And it does all of this so that light speed stays untouched. Because light speed isn't about light, it's about structure. It's about order. It's about what comes next and what can't come before. So when you ask why nothing can go faster than light, the real answer is because the universe values causality more than it values speed. And it will bend everything else to protect that one rule. We like to think of space as a volume, an open area where things can move. And we like to think of time as a line always flowing forward. But in reality, space and time are not separate. They are woven together into a single structure, space-time. And within that structure, there is a kind of geometry. Not the kind you learn in school with triangles and arcs. It's a deeper kind, one that shapes the rules of cause and effect. At every point in space-time, there is a limit, a boundary, a region of influence. Physicists call it a light cone. Imagine standing in space right now. Draw a cone outward from your feet, expanding in every direction. Everything that can be affected by your actions, everything your light, your signals, your reach could ever touch, exists inside that cone. Nothing outside it can be changed by you, no matter how hard you try. And in the opposite direction, draw another cone back into the past. That's where all the things that could have influenced you came from. Everything outside that cone, irrelevant, unreachable, too far away, because even light, racing for billions of years, hasn't had enough time to reach you. These cones define the very idea of causality. They tell us who can talk to who, what can affect what, which events are linked, and which are permanently disconnected. It doesn't matter how clever you are. It doesn't matter how powerful your tools become. You cannot send a message to someone outside your future light cone. You cannot receive a warning from someone outside your past light cone. The universe has firewalls, not of code, but of geometry. This isn't just theory. It's how every simulation, every calculation, every model of the cosmos works. Black holes respect it. Particle accelerators depend on it. The early universe evolved according to it. Information travels through space-time along paths called world-line trails that trace where a particle goes moment by moment. And those lines cannot tilt beyond the angle set by the speed of light. Try to break the rule and the line stops being physical, becomes imaginary, nonsensical, outside the boundaries of reality itself. This is how the speed of light becomes a framework, not just a feature. It isn't a setting, it's a shape. It defines the edges of what is knowable, what is doable, what is even conceivable. And while that might feel limiting, it also gives us clarity, because without those limits, nothing could be trusted. Causality could fracture, consciousness could loop. the future could interfere with the past. But the universe prevents that, not with force, but with form. It writes its law into the shape of space-time. It uses geometry to define possibility. It lets us navigate reality not as wanderers in a void, but as beings tethered to cause, effect, and meaning. The speed of light is the angle of that tether. It is the slope of influence. In every interaction, every signal, every story unfolds inside its cone. There's a quiet trick the universe plays. It convinces us that events are happening now all around us. It's the moon hanging still in the sky, the stars holding their pose. The people we talk to, reply to, look at right there in the moment. But they aren't. Not exactly. There is no such thing as instant. Everything we see is delayed. Even light. So fast we call it immediate takes time. From the moon, 1.3 seconds. From the sun, 8.5 minutes. From the nearest star system, over 4 years. And from the edge of the observable universe, over 13 billion years. Which means when you look into the night sky, you're looking into a mosaic of ancient messages. Some from hours ago, some from before Earth formed. You don't see the universe as it is. You see it as it was, from billions of different moments, stitched together by photons just now arriving. And it's not just distant stars. Even on Earth, light takes time. A video call, a laser rangefinder, a mirror. There is always a delay measured in microseconds, but real. This may sound trivial, but it's not. It means that our sense of simultaneity, the idea that two things can happen at the same time, is not universal. It's local, tied to how long light takes to carry a signal. In Einstein's theory of relativity, this becomes even stranger. Observers moving at different speeds disagree about what is simultaneous. One person might see two events happen together. Another moving past might see them unfold one after the other. And both are right, because simultaneity is not absolute. It's not a cosmic truth. It's a matter of perspective, shaped by motion and light. This is the heart of the illusion. We believe in a universal present, but the universe doesn't offer one. What it gives us instead is a network of local nows, each defined by the arrival of information. When you see something happen, you are not witnessing its presence. You are receiving its past. You are always living in the aftermath of something else. And yet, this delay gives time its direction. If all signals were truly instant, the past and present would blur. You could change something before you observed it. Causality would unthread itself. But because light is finite, events can only influence others after a delay. And that delay sets a rhythm. It gives the future time to unfold, gives memory time to form, gives awareness a structure it can trust. The illusion of instant is necessary for experience. The limit of light speed makes that illusion possible. So the next time you look at the stars, or even at someone standing across the room, remember? You are seeing echoes. You're receiving history. And that's not a flaw. It's the only way the universe can make sense. When people imagine faster than light travel, they often picture liberation. Starships streaking across galaxies. Messages sent in an instant. Journeys that defy the clock. But in physics, going faster than light isn't just about speed. It's about sequence. It's about what comes before and what comes after, and whether that order still makes sense. Because if something could move faster than light, then in some reference frames, the effect of an action could appear before the cause. Not hypothetically. Not metaphorically. Mathematically. Let's say you send a message from point A to point B at a speed greater than light. From your point of view, the message leaves A, travels quickly, and arrives at B a little sooner than light would have. So far, so good. But now switch to a different observer, someone moving relative to you. According to the rules of special relativity, their clock isn't ticking like yours. Their measurement of time and their judgment of simultaneous don't match yours. In their frame, the message doesn't just arrive early, it arrives before it was sent. And that changes everything. To understand why this happens, we need to look deeper at a feature of Einstein's relativity, the relativity of simultaneity. This principle tells us that two events that appear simultaneous to one observer may not be simultaneous to another, if that second observer is moving. For example, imagine lightning strikes both ends of a train at exactly the same moment. As seen by someone standing on the platform, but to a person riding inside the train, The lightning at the front arrives before the lightning at the back. Both observers are correct. Neither is lying. Time isn't broken. It's just relative. Now extend that logic to signals. If you send a signal faster than light, the usual rules of sequence can flip. What was cause becomes effect. What was effect becomes cause. The arrow of time becomes subjective. It doesn't take much to build a paradox from this. You send a faster than light message. In one frame, it's received before it was sent. So the recipient sends a reply, also faster than light, back to you. And in your frame, you receive the reply before you ever sent the first message. Suddenly you're reacting to something that hasn't happened yet, or worse, deciding not to send the message at all because the reply told you not to. And if you don't send the message, how did the reply exist? This isn't science fiction. It's not speculation. It's what the math says will happen if faster than light communication is allowed within the structure of special relativity. Relativity isn't broken by FTL. It's simply too honest to ignore what FTL implies. When observers disagree on now, and messages can leap across time, cause and effect dissolve. And when that happens, the rules we live by, conservation, coherence, sequence, are no longer trustworthy. The universe is no longer a story. It becomes a loop, a contradiction, a collapse. And so, to avoid that collapse, the universe seems to do something subtle and absolute. It draws a line. And on that line, the speed of light. To see how this plays out, let's walk through a paradox, one that doesn't need a time machine or a wormhole. All it needs is faster than light communication. Imagine you have a device that can send signals instantaneously across space, not just quickly, instantly, more precisely, faster than light. You're on Earth. Your friend is on a planet light years away. You send a message, maybe just a simple pulse across space. It reaches him almost immediately, well before light from your last hello could have arrived. To you, it feels like you sent a message to the future. But now, flip the perspective. Your friend is in motion relative to you. According to special relativity, they experience time differently. In their frame, your message didn't go to the future, it went to their past. So they decide to reply. They send a faster than light message back, using the same kind of device. And now, from your frame, something strange happens. You receive the reply before you ever sent the original message. And suddenly, causality folds in on itself. You now have a response in hand to a question you haven't asked. A warning before a danger is created, an outcome before the event, effect before cause. It sounds subtle, but it's not. Because if you act on that information, if the reply convinces you not to send the original message, then the loop breaks. You didn't send the message, but you received the reply. The reply exists because of a cause that never occurred. The result is not just confusing, it's inconsistent. Reality becomes contradictory. This is how faster than light communication creates logical paradoxes, not by exotic technology, but by warping the structure of time. And the more you push it, the worse it gets. Now take the same logic and scale it up. You've heard of the grandfather paradox? The idea that if you went back in time and prevented your own grandfather from meeting your grandmother, you'd erase your own existence? It's a time travel cliché. But you don't need a time machine to make it real. Just send messages fast enough, faster than light, and the same logic applies. You could send a signal to your past self. Warn yourself not to make a decision. Change your own timeline. Create a contradiction. You didn't do the thing you were warned about, but that warning only exists because you were going to do it. What started as a message becomes a logical loop, self-negating, self-creating, an echo with no source. And in physics, this is a problem, because physical laws don't just predict outcomes. They require consistency. They need a way to move forward through time without contradiction. When paradoxes like this appear, it's usually a sign not that the math is wrong, but that the scenario can't exist. Not because it's hard, but because it breaks the logic of the system. It's like trying to divide by zero. The symbols exist, but the result is meaningless. Faster than light communication leads to exactly that kind of breakdown. Not noise, not chaos, nonsense. So to preserve coherence, nature seems to do something profound. It doesn't just prefer the speed of light. It enforces it, not as a preference, but as a defense. Because once you allow information to outrun light, time stops unfolding, starts circling, undoing itself in whatever universe that creates. It's not this one. By now, it's tempting to imagine a loophole, a hidden path, some clever workaround that lets us cheat the speed limit without tearing logic apart. Maybe a new kind of particle, a hypothetical technology, some undiscovered law of nature that unlocks the universe. But physics has already looked hard. And every time we push on the boundary, it holds. No object with mass has ever been accelerated to the speed of light. No signal carrying usable information has ever been shown to move faster. No experiment, no equation, no natural observation has allowed anything at all, to cross that threshold. And the reason isn't just practical. It's structural. You see, the closer you get to light speed, the more energy you need. It's not in a linear way, in an exponential one. Double your speed, it takes more than double the energy. Triple it, even more. Approach the speed of light, and the energy requirement approaches infinity. It's not that nature won't let you go faster, it's that it would take everything to try, and still, it wouldn't be enough. The laws of motion, the principles of thermodynamics, the framework of quantum field theory, all of them bend toward this one rule. No signal, no object, no influence may outrun light. This isn't about preference, it's about preservation. Because if faster than light motion were allowed, even in a limited, controlled way, then the symmetry of physics would collapse. Laws that hold true in every frame would fall apart. Identical setups would produce different outcomes depending on who's watching. The principle of relativity, the foundation of modern physics, would fracture. So physics doesn't just fail to allow faster than light travel, it actively defends against it. Through math, through energy constraints, through space-time geometry itself. The same equations that describe black holes, atomic particles, expanding space, they all conspire to protect causality. And perhaps that's the deeper lesson. The universe doesn't just unfold in time, it remembers its order, it respects its own logic. Every law we know depends on a consistent sequence. First this, then that, cause, then effect, tension, then consequence. Once you let that fall apart, once you allow cause to arrive after its result, you're not just breaking physics, you're breaking meaning. And the universe seems unwilling to do that, so it builds a wall, not a solid one, not made of matter, but a wall made of limits, of delay, of protection. The speed of light isn't a speed, not really. It's a defense mechanism, a firewall between the possible and the paradox. It may be the one thing in nature that cannot be broken because everything else depends on it. So when physics says no to faster than light motion, it's not closing a door. It's keeping time itself from unraveling. Whenever we talk about limits, someone always brings up quantum physics, entangled particles, instant correlations, spooky action at a distance. Surely, if anything in the universe can ignore the speed of light, it must be this. Two particles, born together, share a quantum link. Separate them. Across a room, a galaxy, and still, when you measure one, the other responds instantly. It feels like a secret handshake across the void. It feels like faster than light communication. But it's not. What entanglement gives us is a pattern, not a message. When you measure one particle, its partner's outcome is correlated. But you don't control what result you get. Can't choose a message to send. You're just rolling quantum dice in two places at once and getting matching numbers. There is no signal. No cause leaping across space. Just a shared history, expressed in perfect symmetry. This is where the universe remains consistent. No matter how strange entanglement seems, it does not allow you to transmit usable information faster than light. The correlations only become visible after the results are compared, and that comparison requires classical communication. Light-speed communication. Physicists call this the no-signaling theorem. It's not a loophole, it's a wall. Even the most sophisticated quantum experiments, Bell tests, delayed choice entanglement, loophole-free measurements, agree. Entanglement doesn't break causality, it dances within it. And what about quantum teleportation? Surely that's a kind of instant travel, not quite. Quantum teleportation lets you transfer a quantum state from one place to another, but only if you also send a classical message. Again, light speed is required. Without that signal, the receiver has nothing. the state remains locked in uncertainty. Even here, the universe insists on a delay. The entanglement creates potential. But knowledge, the part you can use, moves at light speed or slower. And deeper still, inside the equations of quantum field theory, the speed of light reappears. Operators commute only outside each other's light cones. Space-time structure remains intact. Even the math is cautious. This tells us something profound. Quantum physics doesn't undermine causality, it reinforces it, because even in its weirdest moments, the universe refuses to let you rearrange cause and effect. It gives you mystery, but never contradiction. That's the real wonder. Entanglement looks like a crack in the wall. But when we examine it closely, we find not a breach, but a pattern. A harmony so precise that it feels like magic, until we realize the spell never breaks the rules. So when people say quantum physics defies logic, they're wrong. It redefines logic, and it keeps the speed of light at the heart of that definition. The cosmos can be strange, it can be playful, but it is not careless. And that's why, even in the entangled heart of quantum space, faster-than-light communication remains a fantasy. Not because the universe is boring, but because the universe is self-consistent, and it guards that consistency at every scale. Let's imagine for a moment that faster-than-light motion were possible. No paradox, no causality collapse, no contradiction. Let's pretend nature simply lets it happen. A spacecraft that jumps ahead of its own light, a message that arrives before it's written, a cause that casually steps behind its own effect. What would that universe look like? It wouldn't look like science fiction. It wouldn't look like progress. It would look like nonsense. Because if information can travel backward in time, if effects can arrive before causes, then every rule that makes physics predictive would break. Couldn't rely on equations to forecast an outcome, because outcomes might already exist before their inputs. Energy conservation becomes slippery. Entropy loses its arrow. The whole language of the universe, defined by what leads and what follows, unravels. Its memory becomes untrustworthy. If the future can speak to the past, then what you remember may never have actually happened. The present might mutate based on timelines that haven't even emerged. Reality becomes interactive, but not in a way we can model or trust. There's a reason our most powerful equations, Einstein's field equations, Maxwell's laws, the Schrödinger equation, all respect the light speed limit. They are tools for describing a universe that unfolds, one event at a time, along a thread of logic. Cut that thread and the fabric loses coherence. You could write laws, but those laws would twist, depending on who's asking and when. You could write stories, but no story would ever have a beginning, middle, and end. Every plot could rewrite itself. Every experiment could undermine its own setup. A signal sent to stop a bomb could arrive before the bomb was built, preventing the setup that created the signal in the first place. This is not a quirk, it's a collapse. And it isn't just the distant consequences that concern us, it's the everyday ones. The way you strike a match, the way your neurons fire in sequence, the way you live your life, assuming that tomorrow follows today, all of that relies on causality being consistent. You don't need relativity to feel it. You feel it when you regret something. You feel it when you plan. You feel it every time you ask what happened and mean what led to it. Causality is not a luxury of physics. It's the foundation of experience. So if faster-than-light motion were allowed, even in one sliver of the cosmos, it would ripple outward, breaking every timeline it touched. That's why nature draws the line so clearly. It's not a wall to imprison us. It's a scaffolding to hold reality upright. The speed of light is not just fast, it's just enough. Enough to connect, cause, and effect. Enough to keep the future silent. Enough to let time be trusted. We may dream of going faster, but in doing so, we would abandon the one thing that lets the universe make sense. Time, we think, is steady. A second here is a second there. An hour on Earth is an hour on Mars. Our clocks tick in sync with the universe itself. But this, like so many things in nature, is only an illusion, one that holds up just long enough for us to trust it. Because the truth is this: time can stretch, not in imagination, not in metaphor, in motion. This is what Einstein revealed in the early 20th century, not as speculation, but as a consequence of the speed of light being constant. If light won't change speed for any observer, then time must change instead. There's no other way to preserve the order of cause and effect. This bending of time is called time dilation, and it is not a quirk of thought experiments. It is real. It has been measured, and it happens every moment, whether we notice it or not. When you move quickly, very quickly, your experience of time changes. Your watch ticks a bit more slowly than the one you left behind. Your heartbeat, your breath, your entire timeline lags ever so slightly behind. And the effect is not just visible in laboratories. Muons, tiny particles born in the upper atmosphere, should decay long before they reach the ground. They don't, because from our point of view, their clocks are running slow. They live longer because they are moving fast. Satellites in orbit, like those powering GPS, experience time differently than we do on Earth. Their clocks drift slowly but measurably, unless we correct for it. Time dilation isn't a theory for deep space. It's a fact of your morning commute. But why don't we feel it? Because in daily life, the speeds we travel are infinitesimal compared to light. The dilation is tiny. Trillions of times smaller than our senses could register. When you ride a train or an airplane, your clock does tick more slowly than one at rest. But only by billionths of a second. Not enough to age differently. Not enough to change your life. It's just enough to prove that time is not what we thought. This is the part that's hardest to accept. Our minds evolved under gravity, under friction, under slowness. We assume that time is universal, that every moment happens simultaneously for everyone. But that's only because we're all moving slowly together. We're synchronized, not because the universe made us that way, but because the distortion is too small to notice. The faster you go, the more that illusion breaks. Approach light speed, and things change. The minutes you experience may become hours, or days for someone who stays behind. You feel normal, but the world outside races ahead. And the reason isn't magic, it's consistency. The universe is trying to hold itself together, to preserve causality while still allowing motion. And so, as you accelerate, it stretches your time to keep you from violating that limit. It's not by punishing you, not by stopping you, but by giving you an alternative. Travel slower through time. The closer you move toward the speed of light, the stranger time becomes. This is not a figure of speech. It's not abstraction. It's what the equations demand. It's what the universe delivers. Imagine a spacecraft not just moving fast, but close to light speed. 90%. 95%. 99.999%. From the traveler's point of view, everything feels normal. Their thoughts unfold at a natural pace. Their heart beats steadily. Their seconds arrive one after another, just as they always have. But outside that ship, on Earth, perhaps the clocks are racing. To an observer watching from afar, time aboard the ship slows to a crawl. A day on board might be a week back home, or a year, or a lifetime. This is not a trick of measurement. It's not a distortion caused by motion. It is the reality of motion. The faster you go, the less you age, relative to others. This leads to one of the most famous thought experiments in physics, the twin paradox. Two twins, identical in every way. One stays on Earth, the other boards a ship and flies close to the speed of light. When they reunite, they are no longer the same age. The traveler has experienced fewer years, fewer thoughts, fewer moments. Their body is younger, their memories are shorter, and yet, for them, nothing felt unusual. They were never aware of time stretching. It did not feel slow. They felt unchanged, because time dilation is not something you experience. It is something others notice when they compare. You could travel to a distant star, 100 light years away, and return, while only a few years passed for you, and a century passed for everyone else. You would return to a different Earth, to the future, to a world that continued in your absence. And yet, you'd have made no machine, no paradox, no loop, just a journey protected by the laws of physics. This is the hidden gift of time dilation. It is not a barrier. It's a pathway to high-speed travel, to the edge of time, without ever breaking the speed of light. And it raises a quiet, haunting question. If someone leaves and they return far in the future, did they travel through time? Not in the science fiction sense, not by breaking rules, but by obeying them so completely that time itself had no choice but to yield. The universe does not allow faster than light travel. It's not a rule you can break with enough force. It's a law that holds up the structure of time itself. But instead of slamming the door shut, the cosmos does something more elegant. It bends. You may not outrun a beam of light, but you can stretch the time you experience while trying. The faster you move, the more space and time yield around you. And the closer you get to the limit, the slower your clock ticks for everyone else. This is not a penalty. It's the cost of preserving causality. The universe would rather slow your time than allow you to reverse it. It would rather warp reality gently than let it fracture completely. That's what time dilation is. It is nature's compromise. Quiet warning. You can go fast, but you must leave time behind. And in that trade, there is opportunity. Because while time dilation limits speed, it also opens a door to something extraordinary. Relativistic travel. If you could build a ship that traveled near light speed, you wouldn't just move through space, you'd leap through time. You could reach distant stars in a human lifetime, while centuries pass for those back home. This isn't fantasy, it's physics. It's a kind of time travel without paradox, not because you violate causality, but because you cling to it so closely that time bends around your path. The faster you go, the slower you age. Your journey becomes a compression, shortcut not across distance, but across experience. And that makes every interstellar dream more poignant, because the price of touching distant suns may not be death or danger. It may be the quiet loneliness of returning to a world that has moved on without you. Time dilation is not just a quirk of motion, it is a reminder that every speed has a cost. Every journey alters more than location. It alters the rhythm of life itself. It all begins with a simple truth. The speed of light is untouchable. But if you reach for it, time will reach back. Time is the one thing we assume we all share. You and I may live in different cities. We may speak different languages. But we both know what now means. Or at least, we believe we do. It's the most natural idea in the world that there is a present moment, stretching across the Earth, across the solar system, even across the universe. That events unfold together, synchronized like a cosmic clock. That now is something real. But this idea, as intuitive as it feels, is wrong. Deeply, beautifully, and irreversibly wrong. Because in the universe Einstein described, simultaneity is not universal. It is relative. The first thing to understand is that this isn't a subtle effect. It's not a quirk you can ignore at great distances. It's built into the very fabric of space-time. Einstein's insight was simple but radical. If the speed of light is constant for all observers, then each observer must experience space and time differently. Their clocks, their rulers, and crucially their sense of what is happening now all shift depending on how they move. This realization unravels the illusion that time flows the same for everyone. Consider two observers, one standing still, the other in motion. They each witness two flashes of light. Say lightning strikes at either end of a long platform. The one standing still sees both strikes at the same time. To them, the flashes are simultaneous. But the moving observer is in a different frame. By the time light from the front strike reaches them, they've moved forward. Light from the rear has to catch up. From their perspective, the front strike happened first. Both observers are correct. It's not metaphorically, mathematically. There is no contradiction, only a shift in how events are ordered. This is what physicists mean by relativity of simultaneity. The order of events depends on your state of motion. It's now for you, maybe already happened, or not yet for someone else. And this breaks something deep in our intuition. It's because we don't just use time to mark events. We use it to make sense of the world. We rely on it to tell stories, to assign responsibility, to remember. But in relativity, time doesn't give everyone the same story. It allows for a kind of narrative flexibility, one in which multiple sequences coexist, none of them privileged, none more real than the others. Not that there's no present, it's that there are many, and they don't all agree. And once you accept that, the universe begins to look very different. To feel just how strange this is, let's go back to one of Einstein's favorite thought experiments. A long train glides smoothly across the tracks. At the exact moment, the middle of the train aligns with the middle of the platform. Lightning strikes both ends of the platform, one bolt at the front, one at the back. For the observers standing on the platform, both flashes of light reach them at the same time. They are equidistant from both ends. The speed of light is constant. So, logically, the lightning strikes must have occurred simultaneously. Now imagine someone riding inside the train. They're also at the middle of the train when the strikes occur. The train is in motion. As the light from the front strike travels toward them, they're moving forward to meet it. The light from the rear strike, meanwhile, has to catch up. So inside the train, the passenger sees the front lightning bolt first, the rear bolt second. To them, the two events were not simultaneous. Same flashes, same light, same laws of physics, but two different observers each, with a different version of what happened when. This isn't science fiction. It's not a philosophical argument. It's a direct, testable consequence of special relativity. It tells us that there is no universal now. There is no agreed-upon moment that stretches across the cosmos, no single clock to which all reality synchronizes. Instead, each observer carries their own definition of the present, based on their motion, their position, and their speed. This becomes especially important at high velocities or across vast distances. A space probe speeding toward a distant star might see two planetary events unfold in one order. While Earth-based observers see them in another, both are correct. Neither is more real. Simultaneity, it turns out, is local, not global. This matters more than we tend to realize, because everything we build, from calendars to communication systems to physics experiments, is grounded in an assumption that time can be synchronized. But the universe doesn't synchronize. It allows for timelines to diverge, overlap, shift. And yet it still remains coherent, because while simultaneity is flexible, causality is not. No observer, no matter how fast they move, will ever see a cause arrive after its effect. Relativity bends time, but it refuses to break logic. Still, the implications are profound. It means that reality is not a single scroll of events, neatly ordered and shared. It's more like a tapestry woven from countless local threads, each with its own rhythm, its own definition of now. It means that your present is not the same as mine, and what we think of as happening together might never truly align. In a sense, we are all in our own bubbles of time, overlapping, interacting, but never fully synchronized. And that, strangely enough, might be what allows the universe to remain fair. To offer each of us our own consistent story, even if no two stories are exactly the same. We often imagine time as a river, flowing forward, steady and singular. A current that sweeps everything along in the same direction, at the same rate. But that image is too simple, it's too linear, too human. In the real universe, time does not flow along a single channel. It spreads, it folds, it intersects, behaves more like a web, woven from the threads of light and motion and observation. Each observer carries a piece of the weave, their own version of now, their own map of which events are together and which are not. What you call present might include a supernova at the edge of the galaxy. What I call present might include its aftermath. Someone else, racing between us, might see both as part of a completely different sequence. None of us is wrong. We are simply looking at the same fabric from different angles. Because in relativity, there is no global present. There's only a local slice. A horizon that defines what light has reached you and what remains beyond your knowledge. Time is not a uniform drumbeat. It's a mosaic of rhythms, syncopated and relative, stitched together by motion and causality. And this, strange as it may seem, is what allows the universe to stay consistent. Because disagreement doesn't mean disorder. In fact, the relativity of simultaneity is what prevents contradiction. It means that no matter how fast you're moving, no matter how far apart you are from another observer, there will always be a consistent ordering of causes and effects within your own frame. No matter how tangled the web becomes, no observer ever sees a result happen before its trigger. This flexibility, this looseness, is not a flaw in the universe's design. It's a feature, a safeguard. It means that physics doesn't have to choose one timeline for everyone. It can support many timelines, overlapping, intersecting, consistent within themselves. And the consequence of that choice is profound. It allows a universe with no central clock, no preferred perspective, no master reference frame. Instead, creates a cosmos that works for everyone, no matter how fast they move, no matter how far they go. A universe where light acts as the referee, where each observer builds their own map of events, and yet all those maps line up at the edges. This isn't symmetry, it's something deeper. It's compatibility. And that's the beauty of it. Relativity doesn't erase the past or deny the future. It simply reveals that time is more personal than we ever imagined. You live inside a web of information, threaded together by the paths light can take to reach you. And every point in that web defines your present. It may not be the same present as mine, but the universe holds space for both. And in that space, it remains fair. Relativity of simultaneity isn't a breakdown of time. It's the structure that lets everyone have a story and keeps those stories from falling apart. We call it the speed of light, but that name, like many in science, is more tradition than truth. Because this limit, 299,792,458 meters per second, is not about light at all. Light just happens to reach it. Photons, the particles of light, travel at that speed because they have no mass. They don't accelerate up to it. They're born into it. They emerge into existence already riding the edge of the universe's limit. But the law is deeper than photons. It applies to everything. Any massless particle will move at this exact speed. Every influence, every change, every signal that can move through space-time without carrying mass is bound to this same velocity. Massive objects, protons, people, planets can only approach the limit, never reach it. The closer they get, the more energy they require. And at the speed of light, that energy becomes infinite. A boundary is drawn not by walls, but by the structure of the universe itself. This isn't about engineering. It's not about what we haven't built yet. It's a law written into the geometry of everything. And if you need proof, you don't have to look at light. You can look at gravity. For most of history, we imagined gravity as an invisible force, a tug, a pull, a signal that acts instantly. When the sun moved, the planets adjusted. When an apple fell, the Earth responded. But that's not how it works. In Einstein's universe, gravity is not a force transmitted through space. It is a curvature of space and time. When that curvature shifts, say when two black holes spiral together, it sends ripples outward, gravitational waves. For a long time, these were just theory predicted but unseen. Then, in 2015, the Laser Interferometer Gravitational Wave Observatory recorded something extraordinary. Two black holes, 1.3 billion light-years away, colliding with such force that they rang the fabric of space-time itself. And those waves, they didn't travel faster than light. They traveled at light speed. Even the ripples in space-time obeyed the limit. Even the geometry of reality refuses to outrun itself. This tells us something astonishing. Light is not the exception. It is the proof. Proof that the speed limit isn't a quirk of electromagnetism. It's a boundary for all fields, all forces, all forms of information. Space-time moves in rhythm with its own rules, and nothing, not even gravity, can skip ahead. The law doesn't say, light is special, it says, this is how connection works. Nothing moves through the universe faster than the speed of causality itself. Light and gravity aren't the only messengers in the universe. Everything that exists interacts. And every interaction carries influence, a signal that something has changed. Electric fields shift, magnetic fields swirl, particles respond to forces they cannot see but somehow feel. But even here, in the invisible interplay of fields and particles, the speed limit remains. When you move a charged particle, when you nudge it ever so slightly, it creates a disturbance. That disturbance doesn't spread instantly. It ripples outward at the speed of light. But this isn't because it's made of light. It's because changes to electric and magnetic fields, what we call electromagnetic waves, propagate at that exact velocity. It doesn't matter if there's a medium or a vacuum. It doesn't matter whether you're near or far. The change moves no faster than the law allows. Even in the vacuum of space where no particles exist and no photons are visible, the field still obeys the limit. Because the boundary isn't imposed by environment, it's imposed by the structure of space-time itself. This holds true for every field we know. The strong nuclear force, the weak nuclear force, the Higgs field. Even in the mathematics of the Standard Model, influences respect the light cone. which means that the universe doesn't just move at light speed, it processes itself at light speed. Reality updates, step by step, never faster than that boundary. And what about quantum mechanics? Surely that's where the strange things live. We've already seen that entanglement doesn't allow communication faster than light. But let's go deeper. In quantum field theory, the most successful framework in modern physics, everything is a field. Particles are excitations, disturbances in those fields. They pop in and out of existence, but the way they interact is strictly regulated. Even in the quantum vacuum, teeming with fluctuations, no influence travels faster than light. When a particle interacts with another, the information about that interaction spreads within a light cone. Outside that cone, there's no effect, no reach, no cause. This is built into the math. Operators in quantum field theory commute or cancel out outside the light cone. That's not an accident, it's a safeguard. The theory refuses to let influence jump the boundary. So even in the domain where things are probabilistic, where particles don't seem to exist until measured, where uncertainty rules, the speed limit still holds. Not because the quantum world is tame, because even its wildness is internally consistent. And that's the real revelation. Speed limit is not a law for macroscopic objects. It's not a ceiling for rockets. It's a fundamental limit on the transmission of any effect, anywhere, at any scale. Whether it's an electromagnetic pulse, a gravitational ripple, or a shift in a quantum field, the message travels no faster than light, because faster would mean causality breaks. And causality, it turns out, is more precious than immediacy. There's a moment when we look at the cosmos and think, surely this breaks the rule, because the universe is expanding, not slowly, not modestly, but at a rate that seems to fling galaxies apart faster than the speed of light. So is the law broken? Has nature made an exception? Not quite. Because galaxies aren't speeding through space. Space itself is expanding. It's not a race between objects. It's a stretching of the fabric between them. Imagine dots on a balloon. As the balloon inflates, the dots move apart. Move apart not because they're traveling, but because the space between them is growing. No dots are outrunning the others. The surface is changing beneath them. In cosmology, this is called metric expansion. It means that regions of space can recede from one another faster than light, without violating the speed limit because no signal, no particle, no information is crossing that gap. In fact, for the most distant galaxies, their light may never reach us. It's not because it's slow, but because the space it's trying to cross is expanding faster than it can bridge. These galaxies pass beyond what we call the cosmic event horizon, a boundary not of light, but of knowability. And yet even here, causality is preserved, because nothing crosses that horizon in reverse. No message comes from beyond it. No influence reaches back in. The rule still holds. No usable information outruns light. Even the growth of space itself, wild and accelerating, is choreographed to maintain this constraint. But what if we try to break the rule anyway? Not with rockets, not with signals, with math. Theoretical physics has a long history of testing the boundaries of its own logic. And when we ask, what if something could go faster than light? The answer comes with an immediate cost. To travel faster than light, something must behave very differently from everything else we've observed. It would need imaginary mass, not zero. Not small, but mathematically imaginary. Its momentum, its energy, its relationship with space-time would all invert. These hypothetical particles have a name, tachyons. They appear in some exotic equations, often as curiosities or placeholders. But they bring baggage. Tachyons would always move faster than light. They couldn't slow down without crossing into paradox. It could be used, at least theoretically, to send messages into the past. And when that happens, causal structure collapses. You get the same loops, the same contradictions, the same breakdowns of logical order that plague all faster-than-light systems. But worse, the equations become unstable. Tachyon fields grow without limit. Quantum corrections spiral. You end up with a theory that destabilizes itself from within. Nature seems to reject them not with violence, but with silence. We've never seen one, never measured one, never needed one to explain any known phenomenon. And that's important. Because when mathematics leads to contradictions, it's usually the universe's way of telling us, this cannot exist. It's not just that faster-than-light particles are difficult. It's that they would break the very canvas the laws are painted on. We often treat physical laws like limitations, restrictions placed on what we're allowed to do. Gravity holds us down. The second law of thermodynamics says we can't undo entropy. The speed of light says we can't go faster. But these aren't just rules, they're definitions. They tell the universe not what it can't do, but what it is. And among them, the speed limit is one of the most fundamental. It's not a fence, but a framework. A signal can only reach so far in a given time. A cause can only influence what lies within its light cone. An observer can only see as far as light has traveled since the beginning. This creates structure, not just in physics, but in reality. Defines which events are connected and which are isolated. Draws the boundary between the knowable and the unknowable. When we say observable universe, we don't mean a physical container. We mean the region where information has had time to reach us. Beyond that, galaxies may exist, but for us, they're sealed off, not by walls, but by delay. That delay is built into the fabric of space and time. It's what allows a timeline to form. Without it, everything would be simultaneous. Every action would touch everything else. The cosmos would be one massive blur of effect without distinction. But with it, stories can unfold. Histories can be traced. Consciousness can organize memory, experience, and meaning. The speed limit doesn't just hold physics together, it holds narratives together. And it doesn't just protect causality, it defines identity, because you are who you are, in part because not everything can reach you at once. Your life has a direction, your mind has a before and an after. Your experience is sequenced, one moment at a time. That is what the limit gives us, not just delay, not just constraint, but order. A way for the universe to make sense. Not just to itself, but to us. And in that sense, the speed of light isn't just a constant. It's a kind of rhythm, the tempo of connection, the heartbeat of cause. It doesn't just bind the universe, it shapes it elegantly, relentlessly, beautifully. Everything you see has already happened. The stars above you are ancient. The galaxies and telescopes are fossils. Even the face across the room, lit by a lamp, exists in your eyes a few nanoseconds behind. You don't see the present, you see a reconstruction, a story patched together by light. Some of it fresh, some of it from 1 billion years ago. And yet, you live as if the world is immediate, as if everything responds in real time, as if now is something shared. It isn't. Not in the deepest sense. We live inside a delay, a symphony of photons, each one arriving on schedule, none arriving instantly. And this isn't a flaw, it's the reason experience has structure. It's why there is a before, a now, and after. Without that delay, time would have no rhythm, events would blur, causality would collapse. The universe would be a single flash with no memory, no sequence, no life. But because of this delay, the cosmos is patient. It unfolds gradually like a wave washing across the shore. It lets stars form and signals travel, and thoughts arise, not all at once, but in order. The speed of light isn't just about motion, it's about meaning. It gives the universe its tempo. It lets time play out, one moment at a time. It makes the act of witnessing possible. So no, you don't live in the present. Not really. You live in a moving horizon, where information catches up just late enough for you to notice, and just soon enough for it to still matter. The universe doesn't just move forward, it remembers, and it waits for light to catch up. This is cosmic canvas, where the universe is not only studied, but painted in meaning. Until next time, keep asking, keep looking up, and never stop wondering.